Hello viewers, hope you are learning and growing your skill set, and this time we are back with another interesting tutorial, and this time we will be talking on performance benchmarking of Postgresql. So before we get started, I assume you should have an instance up and running which is of Linux and preferably CentOS, because I'll be performing this exercise on CentOS, the default Amazon Linux AMI, although you can choose Ubuntu instance as well. So for this exercise I am using a C3 large machine which we have spawned up as a spot instance, and if you don't know how to spawn a spot instance, then you can watch our tutorial on it. And the reason why I'm asking you to spawn a spot instance is that it would be cheaper for you. You can do your stuff in a lesser price. So let's go ahead. Uh, this is our instance. So I'll be doing SSS to this one. So we are inside the instance, and we'll be benchmarking PostgreSQL. And whenever it comes to benchmark your environment, the first thing you should start with is the database. The reason why I'm telling this is because applications rely heavily on databases. So your database should be strong enough, should be reliable enough, and should be optimized enough. And you can scale your application directly, or maybe dynamically is the right word I say. So you can scale your application dynamically by using auto scaling and whatever tool you can use for it. And but you can't scale your database that much dynamically. So it is a once in a while practice, or once in a while exercise that you do to optimize your database. So it is very important to optimize your database uh, quite well. And developers can optimize the code later, and they can continuously optimize the code and deploy it again and again, whereas DB optimization are not that frequent, and actually nobody cares to optimize it that frequently. So these are the reason I am saying to focus on the benchmarking first prior deciding or going to a particular database, or prior deciding your configuration settings. So you should check all the things and then finalize your database environment. So let's start with tuning. So one of the aspect required for optimization is to simulate the traffic to put stress on databases. So we'll be using PG Bench for it. So we'll be simulating database traffic with the help of PG Bench. It is a tool. So the steps would be, the first would be to install PostgreSQL. So as of now, we don't have Postgres installed. So let's go ahead and install it. So first we need to be sudo, or maybe you can use sudo. So I would be root, and then you need to do yum install PostgreSQL server and PostgreSQL contrib. So this will install the PostgreSQL. Once we are done installing, you need to initialize it. So we are starting the PostgreSQL service, and it is up and running. So you can change to Postgres user using su-postgres, and you are inside Postgres users, and then you can use PSQL to interact with the database. So /l will list the databases. So we are done. Now what we will do is we will create a database. So let's create a database, say sample. Okay, the database has created and we can list it again, and here is our database. Now let's quit from here. Now what we will do is, with the default configuration, we will try to simulate a traffic and observe what is the output of the benchmarking tool. So first we will set up a baseline performance. We will see with the default configuration what baseline performance we are getting. So we will run pgbench -i is for initializing, and minus is to scale up. So I'm giving here 50, and then the database name. So what it will do is, by default it will create a 16 MB of database, but this is not enough for us. I mean, 16 DB would be a small database to test on. So with -s option, we will tell pgbench to create DB with 50 times the default size. What this essentially means is that ultimately this is going to create a table which will have very huge record, and the DB size would be somewhere around 50 times of the default one. That is 50 into 16, that is 800 MB. So 800 MB of data would be generated. So let's go ahead and run this. So as you can see, it is creating those many tuples. Okay, so we are done. So it has created the required database for us. Now let's go ahead and check it. So as you can see, it has created these many relations for us: PG bench accounts, branches, history, tellers, and all this stuff. Now we'll run the configuration on this database. We will run the PG bench on the default configuration with this database, and then we will observe the output. So the command is pgbench -c 10, and the another option is J is for threads, and T for transaction, and the database name. So let me explain you this command. -c option is the number of client. So we are saying that access the database with 10 clients, so ultimately 10 sessions will get open. And J option is for number of threads. So we are saying to use 2 threads for pgbench, and -T option is for transaction. So we are saying 10,000 transaction to be run for each client. So let's go ahead and run this. Before running this, let's SSH to the same server and observe the memory usage of this. Oops, something wrong. Let me SSH once again. So the IP was wrong. Okay, so we are inside it. Let's watch the memory usage. So what all the total memory we have is 3.7 gigs, and we are using 1.2, and the available is 2.5. So now we'll be simulating the stress on the database. Let's go ahead and run this. It's going to take a bit of time. Meanwhile, you can have a look at the memory. We were having 2.5 gigs free, and it is as it is. So simulating the traffic is not having much effect on this as of now. Now, what this command is going to give output is that it is about to give us a TPS kind of metric. TPS is transaction per second. So it will tell us with the current configuration, with the current hardware, with the current resources, it is able to perform how much transaction per seconds. So we have got the output. Scaling factor was 50. Query mode is simple. Number of clients, as we said, it is going to be 10. Number of threads are 2. Number of transaction per client we specified should be 10,000. So it has processed all of them. So all transaction has been processed. The TPS observed is 1440. So this is the transaction per second we have observed with the default configuration. Now let's go ahead and try to tune this up. Let's optimize the settings and see what we can do. So let's open the configuration file. So yeah, here's the file Postgresql conf. So here all the strings are specified. So first thing we are trying to tune is the shared buffers parameter. So the default value is set to 32 MB. Now let's try to set it to say 256 MB. And after setting this, you need to restart PostgreSQL. Now we will run the same testing again, and let's see how much it is. Previously it was 1440. So let's try to run this time, and with the same client, same number of clients, same number of threads, and same number of transactions per client. And observe the memory usage here. So previously it was going to somewhere 2.5 gigs were free. Now it is 2.2 gigs are free only. That means some of the memory is being utilized by buffer cache. So what buffer cache is, uh, when a query is run, so PostgreSQL get the data and keep it in the memory for a while to serve the result of the query. And then after serving it, that data get flushes out of memory. So the amount of memory that Postgres can accommodate for the query result, that memory is buffered cache. So the output here is here. So hooray, we have got a performance enhancement in the Postgres. Previously, transaction per second was 1440, and this time it is 582. So we have the increased performance now. Now let's try to do one more thing. You can tune up and you can increase this settings more. You can specify more RAM to it. So we have given 256 MB. Probably you can use 500 MB or maybe 1 GB. As of now, we have enough RAM. Like we have 4 GB of instance. So maybe I can give 2 gigs of RAM for shared buffers. So let's go ahead and try the second parameter. So I'm not changing again this setting and not running the test again. This you can run and check it again and again that at which level the saturation is coming. So we will jump to next tuning setting, that is effective cache size. So default value for this is 128 MB. And what effective cache size is, it tells Postgres to create an execution plan to make best use of available RAM. So what this means is, suppose you have 1.5 GB of RAM and shared buffer of 32 MB, and say effective cache size is 800 MB. Then a query needs 700 MB of data. Then the Postgres estimate that all data can be accommodated into the memory because effective cache size is 800 MB. So all those required 700 MB of data can be fed into the memory by the kernel. So it will use that aggressive plan in terms of optimization, and it will store the data as it is. But if effective cache size is 200 MB, then the query planner is liable to adopt a IO efficient sequential plan. So you should set the ideal value. The ideal value could be max RAM, which would be available to Postgres all the time. So now you might be confused between shared buffer and effective cache size. So essentially the difference lies here is that shared buffers keeps the data into the memory for the time just to serve the result of that query, and then it flushes it out. Whereas kernel takes responsibility to make the cache available even after the request is being served. So kernel takes the responsibility for effective cache size, and this is shared buffer is more of Postgres caching. So this is how the difference is. Now let's go ahead and oops, to set the settings. I by mistake restarted it. No issues. Let's go ahead. So here's the effective cache size, which is default value is 128 MB. Let's set it to 500 MB. Save it. Restart the service. Then go back to Postgres user and simulate the test again. if you try to change all these parameters like shed buffer, effective, and this one, effective cache size, and if you don't find a significant increase in the TPS, then probably you have enough resources to perform, then your Postgres is performing good. uh, uh, Probably you might not have that much sufficient of data to check out those settings. So in that case, you can scale up your database by applying -s option, and you can get it. So you can try changing all these parameters and try to simulate your environment, and then try to configure all these parameters and then run the test. So we have got the output, and this time we have another improvement, and this time we are able to achieve 1655 transactions per second, and previously it was 1582. So this is how all these things contribute for the performance of PostgreSQL database. Now there could be other factors too. For example, auto vacuum, which is again a different topic to talk about, which I'm not going to talk in this one. We'll cover up the same in some other tutorial. So auto vacuum could be another parameter. File system could be another. For example, you have your data on a volume which could be of ext4, which could be of xfs, or which could be architectured in RAID model. So you can benchmark on those kind of things as well. So you can take two instances, one PostgreSQL instance having XFS file system, one PostgreSQL instance having ext4 file system, and you can run the same test on both the instances, and you can observe the difference. Then you can do the benchmarking on the basis of type of OS as well. You can run the same test on a CentOS instance and an Ubuntu instance. So this is how you can simulate different environment, and with respect to different parameters, and do the benchmarking. And you can also do it on like changing the indexing strategy of your database. So you can have multiple indexing strategy, and you can perform the same test on different indexing strategy. So in that case, you would be able to compare that which one is best and which one you should go for. So this is all about this video tutorial. I hope you enjoyed this one. Keep learning, keep sharing. Thanks for watching.